Alright, mastering Solidworks. Chapter 12, editing, evaluating, and troubleshooting. When you use CAD programs, you typically create a part once, but edit it many times. Design for change, also known as design intent, a core most of the modeling work that we do in a SolidWorks chapter where it starts with a very basic editing concept, which you may already have picked up and have reading in this book before beginning. It also contains a summary of the best practice for the model part set model evaluation tools that can help you evaluate the parts. I placed this evaluation tools in the chapter devoted for the editing because creating, evaluating, editing, evaluate cycle is one of the most familiar in modeling and design practices. In this chapter, you will learn to use the rollback to look at results of the design tree, reorder features in the design tree, reorder all features as a folder, select items using a flyout feature manager, summarize best practice for model parts, apply evaluation techniques to plastic parts in complex shape. Using rollback. Rollback model is one of the first and simplest things you can do when examining a model. It simply means you rolling back to look at the result of the design tree selected point of the model history. The order in which you create the features is recorded. If you change this order, you will get a different geometric result. You can use several methods to pull the model in the rollback stated. Drag the rollback bar with the cursor. Click the right mouse button, select one of the rollback options. Edit the feature other than the last one in the design. Editing a feature other than the last one in the design tree, SolidWorks roll back the model automatically. Choose tool, option, feature manager, arrow key, navigation to control rollback bar with arrow keys. Save model while editing feature sketch, then exit the model. When the part is opened again, the rollback to the location sketch was being edited. Press escape during a long model rebuild. This method is supposed to roll you back to the last feature that was rebuilt when you press exit key. However, in this practice, I rarely seen it do this. It usually rebuilds the entire model. Select a face model from the pop-up menu. Select rollback icon. The feature manager will roll back to the point in feature list just before the feature was created. Select a face the geographical area. Select a face on the geographic area. Select the rollback icon. The model will roll back to just before the feature was created. Just before the feature created that face. This is a great technique for quick rolling back before a specific fillet has been applied. Using the rollback bar. Rollback bars typically appear at the bottom of the feature manager. SolidWorks part document enables you to put the part in almost any state of the model history. Rollback bar is not the same as the undo command. It's equivalent to going back in time and changing your actions at a particular point, and then replaying everything you did after that point. Figure 12.1 shows the rollback bar in use. Notice how the cursor changes into a hand icon when you move it over the bar. Understanding consume features when you use the sketch of the feature, such as the sketch-driven pattern command. The sketch over the left end, the design tree of the place was where it was created. However, most other features, such as extrude, consume sketches, meaning the sketch disappeared with the natural order. Feature manager appears indented under the feature that was created from it. Consumed sketches are sometimes also referred to as absorbed sketches. Show feature the natural order instead of their consumed order to show flat. Tree options use Control-T shortcut address by right-clicking on the name of the part at the top of the feature manager under the tree display selection shown in 12.2. Examining the parent and child relationship. In genealogical family tree diagrams, the parent and the parent-child relationship represented with the parents at the top of the children branch below the parents. In SolidWorks, pattern-child relationships track differently. In Chapter 12.3, show the difference between genealogical family tree and SolidWorks design tree. You can display the parent and children relation between SolidWorks features shown in Figure 12.4. Right-clicking into the feature, selecting parent and child. This helps you determine the relationship between you making editing and deletions because you can see the features will be removed or dangling, losing their references. Also, dynamic reference visualization or DRV is helpful, showing both parent-child relationship, however, is shown in Figure 12.4. Alright, it's using the rollback bar on we've now rolled back the bottom of the bar to fillet 4. No, to cut and extrude. So this we'll see the rollback bar, and we've taken out a fillet and the chamfers out of there. So this right here, these fillets and chamfers have been removed. 12.2, selecting show flat. We've picked the part. We've right-clicked about mouse, and we've now picked show flat tree, show features names, and so now we have the flat tree instead of out here. Alright, 12.3, different interpretation, structure, parent, child, and mother, father, child, child 1, 2, and 3, genealogical family tree, child, Solidworks, parent, family, parent 1, parent 2, parent 3. It does not indicate that sketch 6 is a parent of cut extrude 2, that you can turn on the dynamic realization visual through menus, view user interface dynamic reference visualization. SolidWorks parent-child relationship panel with dynamic reference visualization shows the parents on the left would be the cut extrude with and then the child would be in a cut extrude with a chamfer. Thus, we've done front X origin, right roll volt. The parent would be control X and cutted extruded, and then the chamfer. When SolidWorks puts a child at the top, it is in fact turning the relationship upside down. SolidWorks each manager earliest point in history is the top of the tree, but the children are listed before the parent. SolidWorks method stresses important solid features over other sketch and curvatures. For example, you create and extrude the sketch. The sketch exists before extruded into the feature manager. However, SolidWorks places the sketch underneath the extrude. The restructuring can become more apparent when the sketch, for example, sketch 1 is created early in the part history than not used to create a feature. For example, extruded 5 until much later. If you roll down feature manager feature by feature, you arrive at the point at the end of the design tree. Extrude 5 appears on sketch 1, suddenly moves at the location at the top of the tree to under extruded 5 at the bottom of the tree. This scenario may cause a situation where many sketch other features that are created between sketch 1 and extrude 5 dependent on sketch 1, but when sketch 1 suddenly appears after all these features, they can be difficult to understand. But it's a key effective editing parts, especially parts that someone else created. To the main point in SolidWorks displays many relationships upside down. You need to understand how to navigate, manage the history-bound relationship around with the difficulty to understand chronological order features with a compared against relationship with the order feature. Roll back model tree items in item or to work on the flat tree option. Rolling back features multiple parents. To examples such as the loft of the guide curve, the creative of the guide curves first, then the creative loft profile with the reference of the guide curves. The loft automatically reorders the sketch. When you display the loft feature, serves over the search over the profile are listed in the order in which they are selected, followed by the guide curves in order in which they are selected. This is shown in Figure 12.5. The restructuring can be confusing if you want to go back and edit any of the relation between the sketches. The order in which sketches are displayed and not order in which they are created. You can find the example in the download files for the chapter and file number chapter 5 loft WGC solid part. Alright, multiple parent sketch reordering. We have the guide path for our 2 circles here. We're on, and then in the bottom it shows loft 1, sketch 1, 2, and sketch. Using other rollback techniques. Rollback tool is located in the right mouse button. Simply right click on the feature and then either the rollback or the roll to previous. If you're already rolled back, you can right click below, roll click bar, and you can access additional options to the roll forward and roll to the end. Editing any feature other than the last feature also serves as the rollback model while you are editing mode. As you rebuild feature in Sketch, SolidWorks reveals the entire design tree. The tool options view setting of the arrow key navigation enables you with the up and down arrows to keep manipulate rollback bars. Under no circumstances will the arrow keys control view orientation, but they are moved from the rollback bar once using this cursor. Up and down the keys are control rollback bar. Left and right arrows have no effect on the rollback bar. Caution: this one situation where technique does not work. Expected when you are working on a roll part or working on a part that context of the assembly design tree. Roll back. The down arrows simply cover the rollback bar to roll immediately to the end of the design tree. Using Part Reviewer. Part Reviewer is a tool of the SolidWorks that helps you to examine the feature history of the part. You can find Part Viewer on the Tool SolidWorks application. Part Reviewer as a icon over the task pane right side SolidWorks window as shown in Figure 12.6. So it's basically this part with an arrow, a green arrow on it, and that's your part reviewer. The controls at the top of the part reviewer windows are left to right. Jumping beginning to beginning, roll back to the first feature, step back, roll back to the one feature, roll back ahead one feature, jump forward, unroll the entire tree, show sketch details when feature is examined, show the sketch any dimensions as well, show only features when with comments on features which command have been added will be examined. And that is your using part reviewer, part with the green arrow on it, part of your rollback or learning. Smart window under control is our feature name of the currently under review. Pencil icon enables you to edit the feature of the eye. The eye icon will hide the feature of the large window under the comments. The comments added with each of the feature sketch to help anyone who works on the part after you understand anything that might need to be explained about feature. Reordering features. Feature order can make a big difference. The final shape or part. Example for extrude cut fillet shell gives you a very different part from this order. Extrude shell cut fillet. The result of these different orders are shown in Figure 12.7. This part is a split and partially transparent demonstrated purpose only. You remove the part with the download material for the chapter. Final name Chapter 12. Reorder solid part on ordering. Part example of Figure 12.7. The fairly simple to reorder the shell feature for dragging it up the design tree. As a result, we created the cut feature is not shelved around to create a tube. If cut, it comes after the shell. Also notice the shell after the effect of applying the fillet after the shell rather than before it. The considered inside box are shaped while outside corners have been filleted. When you apply the fillet before the shell, the fillets have radius larger than the shell thickness transferred to the inside of the shell. When you're reordering the feature, the symbols may appear with the reorder cursor. They say that you can reorder the selected feature to the location you want. In this case, you want to check with the parent-child relationship to investigate sketch relationship, sketch planes, features, end condition, face edges, selected features such as shell patterns, mirror, and can cause relation to prevent reordering. Also, remember that the flat tree display can be used to overcome some of these issues. If two adjacent features are to swap places, it generally does not matter whether you move one feature of the design tree, move the other down. However, the isolated situation is usually created by the nested absorbed features discussed earlier, with one feature cannot go in one direction, but the other feature can go in the opposite direction, achieving the same result. If you go with a situation where they cannot reorder the feature in one direction, even it appears it should be able to try moving another feature in or their direction. Alright, how the feature order changes apart. We're looking at folder 3, the cut and extrude fillet shell in the shell. We're looking at folder 3, fillet shell cut extrude. So this one shows the it's been put ahead of so now the cut extrude does not yes. So the cut extrude has been put ahead of the fillet in the shell, and then the fillet in the shell was done with a later cut extrude. Reordering file holders. There are two times, regardless of which the features you choose to move, which direction choose to move into your face, the task of moving many feature. It's become time-consuming and tedious, not to mention have potential to introduce error. To simplify the process, you can put all the features to be moved into a single folder, then reorder the folder. Keep in mind that you cannot skip the parent features, and you can reorder the folder only if each individual feature within the folder can be reordered. Best practice folders are frequently used with a group of the feature together. They may be suppressed with the unsuppressed groups. They can also use folders and assemblies. Folders are frequently used with a group of the cosmetic fillet feature. They are often found at the end of the design tree with the plastic parts over the groups of whole features. To create a folder, right-click on the feature, select for the group of the features, select the add to the new folder. Folder should be renamed with the name of the help to identify the content. You can add the reorder the folders in the same way individual features. When you delete the order content, remove the folder, put back in the tree, but the contents are not deleted. You can add the features to remove the features from the folder, dragging them in and out of the folder. Last item in the feature manager for the next feature for the creative is not to put into the folder. You must place it in a folder manually. The combination of flat tree display and dynamic reference visualization can help you quickly answer many of the questions about parent-child relationship within this part. Using Flyout and Detachable Features Manager, Flyout Teacher Manager resides at the top left corner of the graphics window. Is automatically disappeared. displayed something in the property manager covers over the space where the feature manager usually displayed. Property manager goes in the same space as the feature manager sometimes do, big, and to allow this area to accommodate both managers in split window in figure 12A show the arrangement. Alright, well, now we've done a flyout on the feature manager, property manager, and shows history, equation, annotation, equal material to front, top, right, origin, X, Y, Z, and then all the other ones have been grayed out. Flyout feature manager enables you to select item with the design tree. Regular feature manager not available to be covered in property manager. Usually appear with a collapse so they can easily see only with the name of the part symbol. To expand it, click on the plus icon next to the name of the part to flyout feature. Use the flyout feature manager in parts of the assemblies. However, they cannot use the feature manager using transparent flyout feature manager in parts and assemblies. You may prefer not to work with a flyout feature manager because it interrupts the workflow. Covering the regular feature manager with the property manager inhibits it that you can access items you may have to select with the feature manager for the feature with the reference plane. If in this case you select with the detachable property manager instead of the detaching property manager, remove the need of the for flight. I often dock the detachable property manager or flyout manager. Feature manager would go even as use of the undocked onto the second monitoring. The main advantage of the using detachable property manager instead of the flyout feature manager is that with the detachable property manager you don't have to relocate features of the feature manager. They were already in view. Displaying the feature manager of the property manager. Figure 12.9 shows the difference between the flyout feature manager on the left and the detachable property manager on the right. My preference is clearly the detachable property manager. When you have the property manager, you don't have the hunting for the feature for the listed with them right in the front of you. When you're doing something that opens with the property manager, you can put the property manager on the second monitor. In graphics areas, the outside of the Solidworks window, but this works best for the wide aspect with the monitor and with the multi-monitors. You may ask for the difference in what you do with something like the editing sketch for the current state of the feature manager covered. Place with the property manager you have with the new plane, whether you wanted to use the view, especially with the long feature manager for the part where the assembly flyout appears. You again have to scroll to find out the place from the right in the view. However, if you detach the property manager, I think you will find an improvement over the flyout. Detached property manager just displays an editing of the feature of the pole of the property manager tab of the feature manager area with the graphics window releases it, and you can allow the float or dock with one of the flyable dock icons. Following selection breadcrumbs. Selection breadcrumbs is a tool that helps you see what you selected. Any particular item may be characterized in many ways. For example, selecting a face possible that you're selecting the top level assembly, subassembly, an individual part or body, a feature or face, or so on. The selection breadcrumbs identifies exactly what is selected, displays whatever that have been made selection with a graphic window of the feature manager. If you have selected the multiple items, selection breadcrumb displays on the first item you selected. It may display parents and children with the selected item. Then selected item always highlighted in light blue within the breadcrumbs. Breadcrumbs are displayed in part of the document. In the part document, but have more utility in assemblies where mates are involved. We'll revisit breadcrumbs when we start working with assemblies in more depth. Alright, so we're comparing the flyout feature manager with the detachable manager. We have the configuration manager, cut, extrude, and then the flyout over here on the right. So here's the property manager and the right, and then the cut and extrude and the part manager. Note the word breadcrumb is derived from the children's story where the child leaves a trail of breadcrumbs she walks so she knows how to get back home. Breadcrumbs is itself displayed in same area of the flyout manager. Flyout feature manager is shown in figure 210. So now we've done a revolve and we're fly out, and it shows the eyeball shading appearance and then visual assemble part. Displays the selection breadcrumbs control with the tools option. Display shows breadcrumbs on selection. Breadcrumbs are not only information you can select with individual breadcrumbs to make sure that you have proper level of it needs selected. For example, if you selected a face fillet, but you want to select the fillet feature of the first selected face. When the breadcrumbs appears, you can select the feature name. Breadcrumbs are displayed in child features using sketch or planes. Pressing D key will move the display with the breadcrumbs to the location of the cursor. So, we've selected breadcrumbs shown in the detail selection. Summarizing part modeling best practices section. Summary of the best practice of the model part of the best practice of the list important to cover the groundwork for using software which helpful for the new users and users who are trying to experiment with the limits of the with the limits of the software. Only after the respect of the rules, understand the width they are important will know enough to break them. However, the best practice of the list should not be taken even too lightly or nor too seriously. They're not inflexible rules. The conservative starting play with the concept that you can default to, then they're broken if you have the good reason to great extent of the best practice of the rules and function CAD administration. If you are a CAD user, you need to be aware of the suggested rules implemented by a company for which you work with the purpose of the best practice with the standardized procedure so that everyone at your company works at the same models without regarding with the reinventing the method for the guests have something done. If you use at your company with a CAD expert, never create with a model with other than it can't be edited. But then you don't need the best practice. If you have the mixture users, the high-low skill level, everybody needs to train up the defined level and model according to the best practice. The best practice needs to define the most of the difficult tasks, and it can be tempting to have try defining everything in the best practice. But in the long run, you find it more practical to limit your best practice with the only necessary, making sure everything else is covered in the training file and list of suggested best practices. Always use a unique file name for your part. Solidworks, some of the drawings may be picked up with incorrect references with the identical names. Custom properties, great way to enter the text-based information in your part. Users can view the information outside of the file application stuff with the Windows Explorer, SolidWorks Explorer with the e-drawing with the drawing product data management applications. Learn to sketch using automatic relation between fully defined sketches. When possible, splines are often impractical. Fully dimensional limits for your use of the extra constraint. When possible, make relations of the sketch stable to reference geometry such that the original standard place for the inside of the edge of the sketch of the more stable than face for the edge of the more model vertices, which change the internal idea of the slightest change and may disappear entirely with the fillets and chamfer splits and so on. Do not dimension edge created by the fillet or cosmetic feature temporary features. Apply name the sketch features sketches dimensions to help make sure the function is clear. When possible, use fillets and feature patterns rather than sketch fillets and sketch patterns. Combine fillets into the few fillets features as possible. Enables you with the control the fillets need with the control separately, such as filter to be removed, finite element analysis, drawing, simplify configurations added to the rendering. Trade-off with the troubleshooting is more difficult with fillets that use more edge. Create, simplify the configuration, building a very complex, working with large assembly. Build with symmetry in mind. Use feature and patterns of mirroring when possible. Use links to global variables, custom properties to control commonly used dimensions. Do not be afraid of configurations. Control them with a design table when you have more than view ongoing documents. Any of the custom programming automated features in the spreadsheet for other users. Use display states if possible instead of the configurations. Multiple body molded modeling, vary techniques within the part. It's not intended as a means to create assemblies within a single part. Cosmetic features in particular, which should be saved at the bottom of the design tree. It's got an idea to put them all together in folder. Using tools option performance verification on rebuild, setting of the combination with control Q command, check models periodically before calling them. Finish the more complex model with the more questionable some of the geometry of the techniques might be. The more important it is to check apparent part. Always fix errors in your part as you can set as soon as you can. Errors increase the time and the rebuild. If you wait until the more errors exist, troubleshooting may be more difficult to trouble feature sketch errors the more top of the tree down. Do not add unnecessary detail. For example, the more important actual details in the kernel for surfaces, round steel part. Additional detail is difficult to model in SolidWorks and slows down the rebuild over the speed of the part. But there is no advantage to actually having a model unless you're using the model with a rapid prototype or machine. A mold of plastic part where curling cannot be added with a secondary process. Better accomplished by drawing a note. Same concept applies to threads, extruded stacks, very large patterns, other features that introduce complex details. Do not really rely on heavy and niche features. For example, if you find creating a helix by using flex and twist, wrap instead of sweep, you may want to rethink the approach. In fact, you may find yourself creating lots of unnecessary helixes. You want to rethink the approach as well, unless there's good reason to do so. File size is necessary to measure efficiency. Because be cautious about accepting advice information from internet forums. You can both great and terrible advice from people that you don't know, along with everything in between. Sometimes even groups people that can be dead wrong. Getting someone to trust you and verify ideas. Always test your ideas on a copied data to determine if they are effective. If you're CAD administrator for the group users, you want to incorporate some of the best practice trips, standard operation procedure. The more users they manage, the more you need to standardize your system. Using design for change, Solidworks more useful for the traditional being taught with a rebuild each of the feature linear to the top of the one over the became previously. It turns out that not a great idea, especially for the parts more of the complex, which feature dependent on one before it, and the features must be solved in a particular order. If one feature fails, so do all the features that come after that. This is also a slowdown and rebuilding process. Rather than using a linear display daisy chain modeling scenario, you should be base the feature for the entities that are like to fail, change in such a way to dependent downstream from features that fail. In either earlier chapters, I suggest you make sketch relations to other sketch when possible instead of molded edges. For this reason, keep track references. Aim of the techniques help you to organize reference between features of parts eventually in assemblies, such that they make change that they did not plan originally without breaking reference and causing error requiring a lot of model repairing. Underlying problem of the dirty laundry history-based model paradigm helps sweep that under the rug with decades does not handle change for the design intent very well. Experienced users of the familiar with the scenario making a seemingly simple change and seeing feature manager light up with red X's, exclamation marks, a lot of errors. Trying to delete one little feature of the software insists it must also take 15 other more important features with it. In essence, do you need to keep track of the reference and sketch on the face of the feature that created with the feature's face, which becomes reference. The corner of the rectangular picks up the edge created by the fillet. The fillet is part of the parent-child arrangement from sketch. Also, individual parts become more complex. The way models react to change more and more important because each change potentially causes you more and more time. You learn about the consequence of being freed in the context relation, chapter 20, modeling in context. It's one thing to make models quite quickly the first time, edit so should take it less time, not require lots of rework. So how do you avoid a apocalyptic scenario of the design for change? Alright, visualizing a horizontal modeling. Best approach has been visualized with different ways. One technique is horizontal modeling or wide tree approach, where instead of long change of features, you've listed the features all based on the initial plane, such of their own couple of parents, and no grandparents or rules of this type of modeling, such that no reference 3D geometry are allowed. Only references stable to reference geometry initial sketch are allowed. To learn more about this technique, you can begin reading Evans Yard's article on 3D CAD World at 3dcadworld.com, Going Horizontal. Understanding resilient monitoring. Another approach is resilient monitoring would specifically meant with the different types of features require parents of the non-sketch fillets and extruded text comes and at the end of the tree. Resilient modeling created with Richard Gebhard. He has a set of training videos and other information at his web presence at learnrms.com. Using skeleton sketches with handful sketch plane of the feature, centralize the control of all the resolve of the feature, every feature with the set possible related back for the skeleton features such as the fillet shell with the draft of the design, required selection, solid geometry, but other features such as any of the feature created with the sketch can be made only in the reference the original sketch. This is in planes parent-children relation would look very different with the model made with this way. Instead of looking a long staircase, the tree would look more like a tree gets wide very quickly. Therefore, have fewer generations, but each generation would be more populated. Main upshot so of this is any feature fails or the dependent features fails should be minimized. First thing to notice is the air of the feature for the top of the tree that does not cascade down is redo in a stair step model. Second is always to make much easier to find. Model is in construction because all of the reference geometry you to build and set up the few features. Scenario has also potential to be made better with a multiple thread processing because the logic is at least linear and more parallel. Proper design changes discipline. You need to make sure you follow every of the model every day and get sloppy. It's easy to get sloppy. Take easy way out. Reference model edges, sketches on 3D faces unless you're making very simple parts and get everything right from the first time you get come back to it at some point. Using evaluation techniques. You can use evaluation techniques to evaluate geometry errors, demonstrate the manufacturability of the given part, some degree quantify the aesthetic quality of the given part and section of the part. I discuss evaluation techniques here, but the design cycle involves the iterations around the combination, creating, evaluating, evaluated functions. Listing the following techniques in section: verification on rebuild, check, Rubus stripes, real lights, real view lights, and specularity. curvature display, deviation analysis, tangent edges, phantoms, geometry analysis, feature statics, and curvature combs. Many of these techniques apply specifically to plastic part complex shape, but even if you don't involve those areas of the design modeling, the tool may help you to find an answer for the other type of models as well. Special tab to evaluate up here with the command menu. The tab has much of the functionality discovered in the Chapter Plus tool. Plus, the tools menu conveniently located. Search evaluation tools under the evaluated option shown in Figure 1211. You can use commands tab to evaluate parts in several ways, such as focus of the plastic parts and thin walled parts, symmetric parts, so on. Most of these tools are the toolbars are also found in the evaluate tab in the command manager. Alright, in your evaluate tab, you've also looked at the evaluation features. Has a rebuild time, check shade box, region, check another check, say a gauge, a face, justice scale, and a tape measure. You can also look at the go down to evaluate, and the same ones are there available. Using verification on rebuild. Verification on rebuild is that you can activate the tools option performance verification on rebuild. Normal situation setting and turning off. The Solidworks checks each face to ensure that it does not overlap, intersecting improperly with every adjacent face. Each face can have several neighborly options shown in Figure 1212. Verification on rebuild. Show the system operation option, system option performance. You've done the performance. Now you've looked at the books. A verification on rebuild is not checked. When selecting SolidWorks, each face of every face of in the model, the better check them with the setting off to greatly increase the workload. The switch is elected with the default prevent rebuild times going or from getting out of control. For the most part, the default setting is sufficient. However, when the parts are more complex, you need to select the more advanced setting. If you have the geometry rebuild error problem part with cannot understand whether turning on the verification on rebuild option, pressing Control Q apply with the force rebuild command, rebuilds the entire design tree. Control B rebuild command rebuilds only the SolidWorks determines needs to be rebuilt. If you see additional error with the design tree that was not for before the combination verification on rebuild, force rebuild has identified the problem areas of the model, and the features are called if the errors failed. If not, the problem may be elsewhere, so you still need to fix the errors found this way. Performance for speed read, no practice. It's not normal practice to turn off verification on rebuild to use selectively to check models with the potential error. The type of speed degradation used to depend on the number of the face on the bodies in the model. Some of the performance data gradation relieve the patterns documented in Chapter 9, patterning and mirroring. Alright, then it shows the box with a check on it, with a green check on it. Check tools, geometry, invalid faces, other similar geometry errors. It also finds finding open edges, surface of the body, short edges, minimum radius on the face. That needs usually apply a check tool before selecting verification on rebuild option. Check tool points specifically favor the edge of the geometry. Now feature sketch of the cause of the other problem. Check tool finds general faults, locations, and position points, and may or may not have something obvious due to a possible fix. Much of the time, the best tool for tracking down geometry errors with a combination of experience and intuition. It's not very scientific, but you will come to recognize where potential problems are likely to arise, such as those that occur with attempt to intersect with a complex face, with a complex edge, sharp point, and geometry or faces that are significantly from the rectangle with the 90-degree corners. Figure 1230 show the check any dialog box. Alright, in your check any dialog box, you have the stringent solid surfaces, select the items features, all solids and surfaces. You can invalid faces, edges, short edges, found open surfaces, minimum radius, curvature, maximum edge gap, maximum vertex gap. You have a result list and no valid, and then the list of errors and check or close or help. Evaluating geometry with reflective techniques. Evaluating complex shape can be difficult. Subjective evaluation requires on AI for the type of what you are doing, and objective evaluation requires some of the measurable criteria for determining the pass or fail way of the assigned score somewhere in the middle. With the one way the subjective evaluate the complex surface, particularly with the transition between the surface and the common edge of the reflective techniques. If you look at the automobile's fender, you tell whether it is dented, if the dent has been badly repaired, seeing how the light reflects of the surface. The same principle apply with evaluating solid and surface model with the but add transition appear with a crease, unwanted bulge with indentation. The goal is to turn off the edge display. Not be able to identify the edge between the surfaces for the transition to be smooth as the whole area were made with a single surface. With all real view functional SolidWorks emphasize with the reflective finishes and backgrounds emphasize the reflection. Sometimes real view appearances and scenes are all needed to employ reflective evaluation techniques. Chapter 5 using visualization techniques covers all the display information you need to make most of the real view appearance and scenes. Using zebra stripes. Zebra stripes can be activated in 3 ways. Using view display zebra stripes from the menu, clicking on the toolbar button over the view toolbar with the context right mouse menu button. Right zebra stripes places a part in a room there by either cylindrical or cubicle where the walls are painted with alternate black and white stripes. Although you can change the colors and the spacing with a stripe, the part is made perfectly reflective of the way the stripes transition over the edge. Tells you something about the qualities of the face on the either side of the edge and 4 conditions of particular interest. We have CO is a face of contact edge, C1 face of tangent edge, C2 curvature. Each face is equal to edge and transition is smooth. C3 is the rate of change of the curvature. Each face is equal to the edge. The zebra face. Zebra stripes tool can only help you identify CO, C1, C2 only subjectively. This feature of the most value becomes between complex faces. Figure 12 to 14 illustrates how zebra stripe tools show the difference between 3 conditions. Notice on the contact-only model, zebra stripe lines do not line up across the edge. On tangent example, the strip lines across the edges, but the strips themselves are not. Smooth line curvature continuous example, the strips are smooth across the edges of the part, shown in figure 12-14. Surface model can be found with the downloaded materials under the file name Chapter 12 of zebra stripe solid part. Alright, we have contact, tangency, curvature, continuity, zebra stripes, edit colors, cylindrical map, cube map, original surface with zebra stripes, original fillets with edge filleted to be tangent, and original curvature continuous bend between the faces. Tip: you should rotate the model often when using zebra stripes tool. The changing the density of the lines can help you with increasing the image quality. Tools option document properties image quality. Turning off the edge display may also help. You can also use the high HDR hidden HDR images instead of zebra stripes from the file option. This one is lines the most useful local inspection. Alright, using Real View graphic displays available only to the user certain type of video cards. See whether the card supports Real View. Consult with the real system requirements on the SolidWorks website. Real View cause reflection and control in way is similar with the reflection of zebra stripe with the rotate part slowly. Show the watch reflection close across edges instead of black and white stripes. Use the reflective background and apply with the parts of the Real View scene. Using curvature display models, curvature apply within the model face using colors shown in figure 12-15. Accuracy displays leaves a little bit of desire, but does help identify the areas very tight and curvature on the part. Area of the tight curvature can cause features such as fillet and shell to fail. So figure 12-15 shows the curvature display using deviation analysis. Deviation analysis measures how and far tangent surfaces on either side of the selected edge are actually. For example, edges shown in figure 12-16 are found to be fair but not very good. I prefer deviations of less than a half in a degree. Often some of the advanced surface types, such as fillet and boundary SolidWorks, can achieve edges less than 5/10 of a degree maximum deviation. Alright, deviation shows the analyzed parameter edge and calculated maximum minimum deviation. Edit color, minimum deviation. Although deviation analysis helps quantitative measures how to choose to close the tangent with the faces either side of the selected area edge, which do not tell anything about the curvature, so you must still run zebra stripes to make a complete picture flow between faces. Both steps must return good results to have acceptable face transition. Alright, using the tangent edge as phantom settings. Using tangent edge phantom settings is the easiest way to evaluate a large number of edges visually. The function does not do what zebra stripe does, but it gives you a good indication tendency across a large number of edges very quickly. Again, it represents only the tendency, tells you nothing about the curvature continuity, nor does it give you a detailed information. Deviation analysis only tells you with a SolidWorks consider the face of the B tangent across the edge. Several releases ago, SolidWorks widened the tolerance of what it would consider the B tangent, which is both good and bad news. Good is because of the features that require tangencies will work more frequently. It's bad because the frequent fractional tangencies degrees matters to you. Close is not close enough. If you have the tangent edges and phantoms, analysis technique should be follow up to the deviation analysis to find out how close they actually are. I've never seen this function deliver false positives edge display with a tangent where in fact they were not, but I have seen many false negatives edge of the display of the non-tangent when in fact they were. Figure 12.7 show the situation where the edges are displayed with the solid edges, but deviation analysis show them have the 0 degree maximum deviation. Alright, 12.17, use the tandem edges and phantom setting. Measure the tangencies from some tolerances. User cannot control the tolerance, nor does the documentation say what it is. Solidworks says two faces are not tangent at the edge. You can believe that the Solidworks says that the faces are tangent. You still have to ask how tangent. The question is deviation analysis can be an answer. Using geometry analysis, another tool that's fairly new. The geometry analysis you can find in the tools menu. New evaluating tab command manager, extremely useful with the troubleshooting problematic. Geometry property manager shown in figure 12.18 allows you to look for the specific items. Shows a geometry analysis with a check on a box. Short edges, small faces, silver faces. Knife edge vertices, discontinuing faces, edges. You go into the geometry analysis to typically problem spots. Gives you analysis, parameters, and results. And these specific types of the geometry typically cause problems under the other features such as shelf fills and have the difficulty of feature failing with a reason that you can explain. Use geometry analysis tool print with a potential problem spot. This is not a tool that will do your job for you, but will give you useful information to help you do the job better with less guesswork. The geometry analysis tool is available only in SolidWorks Professional and Higher. Alright, and then we have the time on the rebuild button, which is using performance evaluation tool, formerly called feature statistics, have been previously booked for the measure of the rebuild times individual feature within part. You can find it in either tool menu, evaluate tab of the command manager. Performance evaluation lets the rebuild times of each individual feature in part. This is useful for researching features, benchmarking hardware version of SolidWorks, developing best practice recommendation for different tools and techniques. Figure 12.19 show the performance evaluation interface. Comes with print, copy, refresh, and it shows the chapter 12 tutorial finishes, features 18 solid surfaces, total rebuild time 2.85 seconds. Show off well fill it, and it shows all the different features, orders, and time. Overall, I don't recommend relying heavily on the data performance evaluation tool provides because it's inaccurate because the rebuild time is not always the best way to evaluate a model. We can certainly give you the information, but you need to keep it in perspective. A feature that takes a long time to rebuild but gives the correct result is always better than any feature that does not give the correct result regardless of the rebuild time. Using a curvature comb. Curvature comb is a graphic tool that you can apply to a spline, a circle, arc, or ellipse parabola to indicate curvature along the length of the curve. And it looks like a DNA strand, but slightly different. You cannot apply curvature comb to a straight line because the straight line has no curvature. The height of a comb indicates the curvature. Define inverse radius C is equal to 1 over the radius, so that the radius gets smaller and curvature gets bigger. Figure 12.20 show the curvature comb applied to a spline. Notice the spline's continuous change. The curvature arc has constant curvature. Curvature shows continuously changing curvature of the spline. We have the curvature of the spline right there. When a comb crosses a spline, it means that the direction curve has changed from concave to concave down. For example, the comb intersects the spline. It means that the spline at that point has no curvature. So there's the no curvature spline right here in the middle. Surface curvature combs are always available. The right mouse button over a surface, although you need to use the double arrow expanding to the bottom of the menu to see it. This helps you visualize curvature along the UV curve rate of the face is shown in figure 12.21. Surface curvature combs help you to visualize curvature in curved faces. So we have surface curvature combs, faces, display persistent dynamic curvature display, mesh preview, mesh density, curvature combs, direction 1 and 2, edit color, scale, and density. Troubleshooting errors will encounter many types of errors in SolidWorks. Improper installation, even bad computer hygiene can cause errors to the monitor, like bugs in the software. Software bugs cause errors look like training issues. Operator errors can cause problems that are very difficult to sort. I don't have the space on this book to go into all the possible errors, how to work around them, fix them. but I will focus on the feature-related errors that happen in the course of the working on models. When you get an error in Solidworks, figure out what caused the error, how to fix it. Goal troubleshooting error message appears in several places, including a message box on the graphic window, taskbar, tool tip bubbles next to the property manager, and in small symbols of the feature manager window. Interpreting rebuild errors. Chapter 3 works with sketches and reference geometry. Discuss the sketch color of the troubleshooting errors and sketches. You can apply much of the relearning of the troubleshooting sketches to troubleshooting features. In this part, the feature manager displays yellow triangles with black exclamation points, parts with a point out some of the sorts of the warning. Warning means that there is a problem, but the feature has not failed. The red circle with an X in it is the feature is a failure symbol, and it means the feature does not create in any geometry. Figure 12.22 shows the portion of feature tree with the part with the feature in the middle of the tree is deleted. Unless you are very careful about how you set up your part, deletion of the kind will result in lots of errors. So deleting a feature in the middle of the tree can cause many errors. Yes. Notice the tooltip balloon in figure 12.22. Many users get a habit clicking out any of the sort of the warning error message. Shouldn't be afraid of errors, but after you know how to deal with them, you will think of errors to help investigate your model. But the first thing you should do with the error message, read it. Eventually, you'll be able to recognize the error message, the meanings very quickly. The error message could not find any of the surfaces extrude up. That means that you have lost of the top surface at the end of the condition extrude feature for this because the feature was deleted, possibly renamed trim or knit command. You may know the cause of the errors. You may not. Inherited this part from someone who didn't explain the state of the model to you. You might have to figure out it for yourself. Most of the time, it's not difficult to figure out what's going on, especially with a little practice. If there's one thing I can guarantee you, if there's going to get a lot of practice in evaluating errors, inherit model of the errors, the first thing you should go do is look back for the error highest in the tree because of the nature of the high history of the base feature trees. Errors always cascaded down. When you make changes with the cause of the error, these errors will be lower than the tree. Then the change special situation can arise. The change caused the error up to the tree, but they are rare. Again, flat tree display dynamic relationship visualization to help you understand these situations. Alright, identifying common errors. Here are some common error messages, what they're really trying to tell you. Some items are no longer in the model. You can reselect the items using edit definition in the feature manager's design tree. First thing you know is here the edit definition has been gone for several releases now. The name of the command is to look at the edit feature. You can get this message when an edge or a face of a selected feature no longer exists. A number of the things you can cause it may be a culprit, usually change to the model upstream. As a result, you roll back the model and make changes, especially when deleting something. Adding the features can also cause errors of the sort. You can expect some problems when you unroll the model. Operational fail due to geometric condition. This is one that frustrates lots of users because geometric condition vague, but it could mean just anything related with the geometry. Sometimes maybe the selection set with incomplete features require another face and another edge to be selected in order to work. The fillet cannot work because any of the edge flips complexity. Sketch line does not cut all the way across the solid body. There are too many features to list. The clue indicates that you need to check either the selections for the feature of the body on which the feature is operating in more complex cases. It might mean that the part has some geometrical errors that need to be figured out by using check tool or verification on rebuild. That's operation failed due to the geometric condition. Warning: the sketch contains dimension relations to the model geometry which no longer exists. One of the better messages. This is one of the better messages Solidworks provides. It's fairly self-explanatory. It goes on and gives you a couple useful suggestions as how you might fix the problem. Some filleted items are no longer in the model. Edit feature reselects the items when all the edges selected the fillet feature are suddenly not there. The entire fillet feature fails because there's nothing to do. This warning displays the red circle with an X in it, and some edges may remain selected. Fillet feature can still work. In these cases, you will get the message with just as a warning rather than an error. Alright, warning edge for the fillet or chamfer does not exist. In this shape that you see of the yellow triangle, the warning should with a fillet that creates some of the fillets, but one of the selected edges is missing. A feature that can create all the fillets for the created originally. But the fastest way to check this warning is to right click it and select edit feature. Immediately click the green check mark icon. SolidWorks display with a message to make sure that you want to just remove the for reference for the missing edge, but continue with the create the fills for the selected edges. Another option to find the missing edge in the selection box and reselect an edge for the take of its place. Many more types of errors exist. Rather than going through the exhaustive list, which would require another book of its own, I would like to impart you to some of the guidelines to help you find the useful answer. I hope you have one of them to figure out the error once. You will remember it next time you see it. Here are some of the general guidelines troubleshooting errors where the cause of the error aren't obvious. CAD does not look like line-on-line geometry. SolidWorks, you don't have extra points for being close. Most features require you to be exact. It's often a good idea to overbuild geometry so that it's bigger than it needed to be and going to be merged with the other geometry. Zero thickness errors, difficulty to diagnose. Zero thickness errors can be some of the most difficult errors that users who are new to 3D diagnose, much in the same way that CAD does not like the line geometry. It does like edges to create a section of a single body where there is an error on two sides of the edge. If you were to extrude two rectangles with a touch at a point, the SolidWorks would create two separate bodies from that point because it is physically wouldn't fall apart if it were a single body. If two touching rectangles were also trying to merge with existing solid body, you would get an error. Planier means planier. If you click a face, if it just won't let you open a sketch, maybe the face is not planier. Errors in the sort can happen for the application imported with geometry quite often. If you use a sketch icon quick test for whether the face is planier, SolidWorks does not really give you another way to measure this. Planier faces can also cause lots of trouble with assembly mates. Even if it's planar, it's a square coordinate system. If you work with plastic parts, casting, anything else that requires a draft, you can and probably do have faces that are not perpendicular parallel to the chain of reference planes. This causes problems with the projection extrusion direction. For example, a circle projected at an angle becomes an ellipse, and an ellipse projected at an angle becomes a spline. If a SolidWorks does not like one method trying to another produce a similar results, an example of this is a constant radius fillet won't work. You think that it should work. In this case, you try to use variable radius fillet and all the same radius values. For most errors, a rational reason exists. Believe in supernatural forces is not likely to be useful with troubleshooting errors in SolidWorks. If you're using very common features such as extruding cuts, run into errors, it is very unlikely that you have found a bug. Although bugs in sketches are quite common, generally speaking, the more traffic the feature sees, the less likely you are to find bugs. With it, sometimes you determine whether the problem is with the software. Without something you're doing is the toughest thing in the troubleshooting. General users are far too eager to assign blame to the software. Alright, dismissing errors. Some of the errors have a don't show this again box. Don't get in the habit of checking that box unless they're very familiar with the cause of the error and how to fix it. Missing an existing error is much more costly than acknowledging redundant errors. What's wrong box from figure 1223 gives a list of the errors existing model. Some people find it embarrassing to remind about the errors, especially if the people have a habit of looking for your shoulder while you're working. Errors are in red, warnings are in yellow. The difference between the feature that fails is red and the feature that is just partially failed. As a fillet, it is missing a selected edge, but the rest of the edges have been filleted, and it shows what the wrong with to give the symmetry of all the errors in the current box. Which wrong box can be turned off as soon as it's displayed each time the model is rebuilt. You have this option many of the error, the warning message. Each time the message is turned off this way, add a list of the dismiss message system options shown in figure 1224. You may come up with against a situation where you want to change how to respond to repeat warning message. This bot can fill up with a lot of messages, so think twice. Make sure that you understand the issue before missing a warning message. Alright, so figure 1224 shows list of dismissed messages often found in system options. You go to system options and then you go to system options and then you can pick on messages, error, and warnings, and then you can using SolidWorks RX and Performance Benchmark. SolidWorks provides a couple of automated troubleshooting tools, SolidWorks RX and Performance Benchmark. SolidWorks RX troubleshoots your system and at least records facts about your system so someone trained in how to view the results can diagnose the problem using SolidWorks RX. SolidWorks RX is a diagnostic tool SolidWorks provides that helps the support text to solve problem, helps to solve it yourself. You can accept the SolidWorks RX through the Windows Start menu, all programs, SolidWorks 2008, SolidWorks 2008. SolidWorks RX shown in figure 1225 show the home page of the interface. Shows Solidworks RX home diagnostic troubleshooting system maintenance problem capture and reliability, and that comes with a safe mode and a diagnostics mode and. The diagnostic tab of the Solid RX interface is a self-help diagnostic tool shown in feature 1226. This points out that my computer compatibility with my video card that drives out of the date. It gives me the option to download the correct driver. Also lists other information related to system maintenance items, dialogues, and diagnostic tabs. Support detective might ask about if you were to call the crash problem. Some of the other problem might be related to general system issues. Running Solidworks RX before calling a tech support could save you time and make some of the more self-reliant. Troubleshooting tab contains most likely link on the Solidworks knowledge base. You need subscription login. These links are useful and good idea to check with them before calling the tech support. Using SolidRx diagnostic tab, and then SolidWorks maintenance tab contains path of critical SolidWorks system folders. You click the start maintenance button on the upper right hand corner. SolidRx clears all files from listed path. Use browse button. You can clear paths individually, generally temporary backup folders. So make sure you do not need any of the files before clearing them. Figure 227 shows system maintenance tab. Problem capture tab. Often when you call the reseller tech support asking for help with some sort of difficulty, it isn't really explained. The technician asks you to submit a SolidWorks RXL log file. The log file includes information on the other tabs along with the optional description of the problem. SolidWorks files that were in use when the problem occurred. A video problem actually happening. Figure 28 show the problem capture tab, reliability tab. SolidWorks RX show the history of the SolidWorks consistent over the last 2 weeks. The history helps your tech support people and your CAD administrators see how much trouble you've been having with the crashes. The red dots denote abnormal terminations. Reliability tab shown in figure 1229. Files and logs tab. File and log tab summary with the issue, the list of all the files with included RX package. You can click the files, have they added to the view of their contents before sending the package file. Log tabs are shown in figure 1230. 1227, the clearing temp files, the system maintenance tab. 1228, collecting information problem capture tab. Using performance benchmark, SolidRx has an add-in tab that allows all add-ins developed to extend the RX functionality. The performance benchmark runs an installation SolidWorks with the sum of the automated display rebuild exercises. Measure the time of the various operations such as zoom, rotate, rebuild part, and assembly. Figure 1231 shows the interface for the benchmark test. 1229 shows reliability test, gives you a record and sections of crashes. 1230 shows listing files are sent to the RX package. Benchmark, some of the spec APC benchmark, which can be used with several different CADs. Spec APC still exists and available to spec.org. SolidWorks specific portion of the benchmark was listed, updated in 2015. The point of the benchmark list for the measure hardware capabilities. Models of the SolidWorks RX performance benchmarks are small stamp part and injection mold die set. Figure 1232 show the benchmark in action. You can also submit your results to SolidWorks website where they are posted immediately after you compare it for comparison. This is used to help people to make the decision about the hardware to buy. Figure 1231 shows running benchmark performance benchmark. 1232 putting the computer through the paces of the benchmark performance benchmark. You can also check out the compared scores with SolidWorks.com, SW support, shared score.html. Look for the list to see which kinds of hardware receives a consistently high score, which is not represented at the top of the result. You can find more information benchmarking SolidWorks, SolidWorks.com, SW support benchmarks, HTM. Alright, tutorial utilizing editing evaluation techniques. In this chapter, we will make some more edits for the existing parts. We'll use the symbol loft spline commands. Will work with the rollback state features order, and as well as some of the evaluation techniques for all these steps. Open existing part of the file name or chapter 12 tutorial. Start with the solid part. Roll the part back. Step through the feature. See how it was made. Edit the loft of the feature to create with the help of you to understand how the part was built. Exit the loft command. Remove the rollback bar back to the bottom of the tree. Open the deviation analysis tool. Tools evaluate deviation analysis. Select the edges shown in figure 1233. Deviation parts analysis. Select and right mouse button. Select the tendency. The maximum deviation over 10 degrees, which is far too much of the part, needs to be the smooth cut, which could be doing using splines in place of the lines of the arcs. First step is to make the outlet with one piece of the spiral. You can do this with a fit spline. You need to create a fit spline before the loft of the profiles. After the spiral, expand the loft. Roll back between the loft feature of the sketch. First sketch, click OK, respond to the prompt, then roll back just after the spiral is shown in figure 1234. You can also use the flat tree view, right-clicking on the name of the part over the top of the tree with selecting the tree display flat tree view. We've rolled back just after the loft. We rolled back up to the loft just after the loft, and that so sketches 2 and 3. You have chosen to roll back sketch 3, which is absorbed and featured one loft. The following feature will be temporarily absorbed with edit purposes. So sketch 2 and 3 have been temporarily unabsorbed. Right-click Spiral Feature Manager, show it, open a new sketch on the top plane, draw a tangent line outer edge of the spiral. You will notice that you cannot reference to the end of the spiral. Working with curves that absorbed on other feature for the notorious difficulty. Generally, you select curves from the Feature Manager to do anything with all of them. Also, you need to reference the end of the absorbed curve that you can better off the convert entities to make it into the sketch entity. Notice that you cannot select the spiral from graphic windows even when selected with the Feature Manager. It appears not to be selected with the graphics window. Ensure this is select the Feature Manager, and then click Convert Entities button on the sketch toolbar. Draw a tangent line out the outer edge of the spiral dimension of 3 inches long, shown figure 3:1235 with a slight angled upright. So now we've done preparing the fit spline with 3 inches upright spiral. Select both the converted spiral and line. Select two of the spline tools and fit spline with select the tolerance of a tenth of an inch. Make sure that only the constraint option is selected. Click OK to accept the fit spline. Make sure that the single spline is created by moving your cursor over the sketch. See about the whole length of it's highlighted. The goal is to make sure that the curvature comb is automatically appear if this shows smooth transition possible between the converted spiral and the straight line. Note the fit spline feature fits of the spline instead the sketch entities within specified tolerance. It can be useful tool for smoothing out sketch geometry. Exit the sketch, create a new plane, choose insert reference geometry plane for this menu. Select with the fit spline first reference to the outer end of the fit spline, second reference, click OK to accept the new plane. This is illustrated in figure 1236. Creating a new plane, we've done created a new plane file name, first references, perpendicular, coincident, second overends, coincident project, and display, third reference and option. Draw roll back down to sketch 3 and loft 1. This goes back to beyond loft 1, then need to navigate back to the position again. Right click sketch 3, edit sketch plane, select the newly created plane 1 from the file feature manager, click OK to accept change. Notice that the loft profile has moved to the place where it does not belong. This is because the sketch has a pierce constraint to the spiral. There are multiple places where the spiral pierces the sketch plane. Edit sketch, delete with the pierce constraint on the sketch point on the middle of the construction line. Create the coincident relationship between the sketch point and the outer end of the fit spline. Is shown in 1237. The most easily done by dragging the point into the sketch onto the point of the fit spline. Do not exit the sketch. So we've now dragged that to there. Sketch 3's new location. Only one of the goals of the edit is smoothed out. This part of the remember with the deviation analysis tool. Hold the edge of the creative between the lines of the arc in sketch 3 with a not very tangent. For the reason, it would be a good idea to replace the lines and arcs in sketch 3 with another fit spline. Right click on one of the solid sketch at sketch 3 and select the chain. Create another fit spline using same technique in step 8. Again, keeping an eye on the curvature comb to make sure that the curvature around the connection between the lines and the arc does not vary too much. Edit sketch. Drag rollback bar down one feature so that below the loft. Notice the loft feature has failed. If you have the cursor over the feature icon, the tooltip confirms this by displaying the message loft feature failed to complete. Edit the loft feature expand with the center line parameters panels. If it isn't already expanded, delete the spiral from the selection box in its place. Select the spiral fit spline. If the loft does not preview the check-in, ensure that the show preview option is selected in the option panel at the bottom. If it still does not preview, right-click on the graphic window, select Show All the connectors, position blue dots on the connector so it looks like a figure 1238. Alright, position connector dots, and approximate corresponding locations of the two low profiles. Click OK to accept the loft. Loft should be much smoother now as it were before. Check with the right click on the surface, select the surface of the curvature combs. Remember, you might have to expand the right mount menu button To addition, spiral features should be no longer under the loft. It should now be the first item in the design tree. If there are any of the irregularities of the loft, edit the number of section slider, center line parameters, panel to slider middle instead of all the way to the right. Draw the right rollback bar down just before the shell feature. Notice the fillet 5 has been failed. Move the cursor over the fillet 5. The tooltip to helps you if some of the referencer is missing. Edit fillet 5. Select edges in order to create fillets as shown in figure 1239. Preparing the fillet, making selection of fillet edges, and then right click on the end design tree. Select to roll to end. This cover the feature manager to become unrolled and all the way to the end. All the involved no longer as it should be. This become the original extrude with it never deleted in the end. The right click of the extrude feature and select parent and child. Feature needs to be deleted, but you need to know what will be deleted with it. 23. The shell is listed in child extrude because the end of the face of the extrude was chosen to be removed by shell. Edit shell feature. Remove the reference for the face of the A shell feature with no face to remove this still hollowed out. Right click extrude 1. Select parent child again to verify the shell feature is no longer listed as a child. Delete extrude 1 when dialog box appears. Press Alt F to select also delete absorb features. Edit shell features. Select large end of the loft. Exit shell feature. For these results up to step are shown in figure 1240. Okay. Drag window over the design tree to select the 4 fillet feature. For the right click, we'll select the add a new fillet folder. Rename the new file fillet folder. Click the section view tool with creating a section view with using the front plane. Reorder fillet folder after the shell feature. At this point, you should notice that something doesn't look right. This becomes the creating the fillets after the shell causes the outside fillet to break through some out of the inside corner. The fillets should have failed but have not, and shown in figure 1241. Fillets that have failed, and then choosing tool option performance, select verification on rebuild, then click OK. Existing performance menu, press Control Q. Fillet should never now fail. Click undo, return the feature order this way it was. Make sure to turn off the verification on rebuild option because it is unnecessary to slow down rebuild times. Save the part. Alright, the bottom of the line. Working effectively with feature history of the even complex models requires the work of the parts that others have created. When I go back and when I get a part someone else, I usually look at the feature manager, roll it back possible to get an idea of how the part was remodeled. Looking at the sketch relation, feature order symmetry, redundancy, sketch reuse, so on are important steps to being able to repair, edit any of the part using modeling best practice techniques. Helps to ensure that when the edits have to be done, they are easy to accomplish, even if they are done by someone who did not build the part. Evaluation techniques are really hard of editing, as you should not make too many changes without basic evaluation of strength and weakness for the current model. Solidworks provide a wide array of evaluation tools. Time spent learning how to use these tools and interpret the results, so it's time well spent. Master it. Set the test following easy using settings. Test the following settings. Make sure you are know where to find them and where they do. Arrow key navigation feature menu. Flyout feature manager. Selection breadcrumbs. Dynamic reference visualization. Show flat tree. Master it. Use the part for the download material called the horizontal solid part. This part with a simple sketch of the drive and the entire part. Take a look through the part and try to recreate the one that is similar. Master it. Edit the previous part to see if you can make the features fail with a particular reorder some of the fillets. Next, to try something with a part called vertical solid part, which is provided with download material. Examine the vertical part. Try to figure out why the reordering fillets causes so many failures. Part 3. Working with assemblies. We've made it to part 3.